Okay, let's give you guys some more practice. So given this function here, copy this diagram and on top of the diagram sketch the inverse function. Okay, so remember in one of the earlier videos I said that well, I showed you that the inverse function it's really a reflection along the y equals x line here. So the inverse function will look well, it will be a reflection along this diagonal line here. Okay, so well, anyway, so given this function here, sketch this diagram and also sketch a graph of the inverse function. Okay, so press pause and have a go. Okay, so to do this here, well, if you look at the diagonal line, this is y equals x. So that means when x is 1, this here is 1. When x is 2, this here is 2. Well, blah 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 here. At this point here, let's just say for argument's sake, it's 5. So this is also 5. So when you reflect this along the diagonal line, this point here stays the same. Okay, so we know that our reflection, our function, our inverse function here, it will be the same at this point. Now let's look at this one here, this point here. Imagine so at the moment you've got like a machine f of x here, f of x here. Let's just say from here to here is well, at the moment you've got f of x here. This function here. Well, when you put 0 into this function here, so when you put 0 into this function here, it will spit out the number. Let's just say it will spit out this number 7. Okay, it will spit out the number 7. Now the inverse function. Now the inverse function here, if you put the number 7 into this function here, it will then spit out the number 0. So that means well, our inverse function would be, well, if you put in the number 7, that means it's you going across by 7 here. Like, by 7 here. Hang on. So it's you going across 7 because you're putting the number 7 into the machine and it will spit out 0. That means you put in the number 7, so it will spit out the number 0. So it's going to be at this point. My point is that this point here, it will stay the same. This point here, let's just say it's 7 up. Then it's going to be 7 across. So so this distance here will be the same as this distance here. So we've got this point, and we've got, let's say this is roughly 7 around here. Okay, and remember, we are just trying to sketch the mirror image of this line here. So at the moment, imagine you placing a mirror along here, okay, along the diagonal. So this bit here is going to look something like this, okay, because this bit here, when you reflect it, it will look like this, okay. This bit here, reflect it, it will look like this. Try and find some more key points. So here, let's look at this key point here. Here, well, if you think about it, f of x here. When you put in, let's say this is minus 10. If you put in minus 10 into this machine, it will then spit out, well, it spit out 0. Now the inverse machine is, the inverse machine here. If you put in 0, it will spit out the number minus 10. Let's just say it's minus 10. So that means at this point here, if you put in 0, that means if you are at 0 here, it will spit out the minus 10, which is somewhere down here. My point is that at this point here, this distance here will be the same as this distance here, because you put 0 into the machine, it will spit out whatever's over here. Well, the mirror image of this point here will be somewhere over here. Okay, the key point is this distance would be the same as this distance. Okay, and remember x, this point here, it will be the same. This point, this bit here will be the same as this bit here. So let's just guess. Well, this bit here, the top bit here is easy. When we reflect it along this line here, it will look something like this. And now it's just a matter of this is just a matter of developing your own technique. There's nothing technical to learn here. It's just a matter of trying to use your common sense to somehow draw the mirror image of this. Well, this is going to go down like this. Well, it's going to count. Yeah, it's just a matter of well, this distance here will be the same as this distance here. So I'm going to say around here. And it's just a matter of playing around. It's just a matter of guesswork, and then you will improve over time. Remember that this quadrant here, when you reflect it, it will get reflected over to here. So this quadrant will get reflected to over here. Okay. So well, somehow you've got to try and draw the mirror image of this. So maybe guess something like this. Remember that this point here would be somewhere around here. So maybe something like this. And then this distance here will be somewhere down here. So it is a bit of guesswork here. So when you reflect it, just imagine you placing a mirror down here. Okay, so it should be a mirror image. Somehow develop your own way of doing this. Well, your drawing is probably going to be better than mine. Well, I'm going to guess something like this. Okay, so this here is your inverse function here, f here, and it's not 100% accurate, but if you were to draw a diagonal line, if you were to draw this diagonal line here, it should be a reflection. Okay, well, it is a bit of guesswork, but develop your own way of doing it. There's nothing technical to learn here. It's just a matter of playing around and trying to get the mirror image of the original function. Okay.